Today we'll be doing Geometry Section 4.2. We'll be continuing with studying triangles, but today we're going to look at not only classifying triangles, but comparing the angles and looking at what happens to the angles within of a triangle. Now you probably know that within a triangle there's only three angles, okay? So if we look at these three angles and we could put a protractor to this, if we were to take this angle and let's say this is 40 degrees, and then let's say we come over here and we say that this guy is 60 degrees. If we put a protractor to this, I would guarantee that this guy up here would be 80 degrees. Well, now, if you look at those three angles, and this is going to be familiar kind of to you with what we've done in the past, but if we take these three angles and we add those three angles, 40 plus 60 is 100, 100 plus 80 is 180. Now, no matter what kind of triangle you draw, you could draw a really skinny guy like this. These three angles within that triangle are going to add up to 180 degrees. Okay, that's the theorem that we have here. That's called the triangle sum theorem. That simply states that the three angles of within a triangle, three angles in a triangle, I should say in a triangle, because we're going to look outside of a triangle as well. The three angles in a triangle add to 180 degrees. So there's that magic geometry, that 180 again. You know, we talked about a line, and then we talked about these guys, triangles, as well as adding up to 180 degrees. What that means is that if I kind of took some scissors and I cut this triangle up, and I put this angle next to this angle, next to this angle, those three guys would form a nice straight line. This angle, and this angle would form a nice straight line. So that's the triangle sum theorem. Three angles in a triangle add up to 180 degrees. Okay, let's go ahead and use that now. So we look at this. It says write an equation to find the missing angle. Now the reason we're going to do this is so when we get to those big point problems, and really these are going to be nice quick solves. Okay, so if we look at this, let's find the measure of angle x right here. To do this, we know that x plus 70 plus 45 equals 180 degrees. Okay, so there's the equation that we can use to find the value of x. Okay, now what we want to do is we want to go ahead and find the value of x. Well, all we have to do here is add these two guys together, and we would get something like x plus 115 equals 180, and then we got to just subtract them. Okay, so really all we're doing is we're going to add these two angles together, and then we're going to subtract that from 180, and that would give me an angle of x as being 65 degrees. So that angle up there is 65 degrees. Right? And again, we could double check ourselves real quick and easy. If we add these three guys together, 65 plus 45 is 110, 110 plus 70 is 180. Right? So that's the triangle sum theorem. All right, now if we look at number 2, we can write a quick equation. We can go x plus 50 plus 62, and all those angles added up equal 180. Well, now what we're going to do is we're going to add our two angles, 50 and 62, and that would give me 112. And then all we got to do is just subtract that from 180. So we're going to take 112, subtract that from 180, and we get 68 degrees. So this angle right here would be approximately, or would be 68 degrees with the measurements that I have. All right. All right, let's go to the next one. Again, what we could do here is we could write the equation real quick and easy. X plus 40 plus 90. Now in your homework, I'm not going to do that because you know that when we add all three of these up, it's going to equal 180. So all we have to do is add those two guys together, and we got to subtract that from 180. So 180 minus 130 is simply 50. So this angle right here is 50 degrees. There's a nice 40, 50, 90, a nice pretty right scalene triangle. This would be scalene because none of these sides are equal. Alright, number 4, we would do the same process. Here's our equation. X plus 20 plus 32 equals 180. No, you're not going to have to write the equation every time on the homework. I just want to show you that for here in a second. So then what we would do is we take 20 plus 32, that's 52, so we'd have x plus 52 equals 180. Well, all we have to do is subtract that 52. So you're saying, well, Mr. Jared, can't I just take 20 plus 32, 52, and subtract it from 180 already? Yes, but I want you to get in the habit of writing that equation down so when we get to those big guy problems, you're going to be ready to go. Well, now you take 180 minus 52, and you're going to end up with 128. 128 degrees is this angle right here. Okay. Again, look at it. Does it make sense? That's an obtuse angle. Well, that's an obtuse degree measure, so we should be good to go. All right. Find the value of the variable. Now what we're doing here is we're looking for x, and then we want to find all the missing angles. Okay, because if we look at this guy, uh, we know we have a 110 degree angle. We're missing these two, so we're going to find x, and then we're going to go back and find those two, which are actually the same. And we'll just put them in the drawing. All right, so let's start setting this up. Now, set this up. We're going to do it exactly the way we did it here. We're going to add all three of our angles together and set it equal to 180. So we would go x plus 110. Now, it doesn't matter what order we start adding in there. That's the commutative property. But we know when we add all three of them up, we're going to get 180 degrees. Okay, well, now we can simplify this a little bit. X plus x is 2x plus 110 equals 180. So let's go through our algebra. Minus 110 minus 110. 2x, oops, sorry, 2x. 2x equals 70. We would divide by 2, and x is 35. Okay, so now what we know is we know the x value is 35. So that means that this angle is 35 degrees, and this angle is 35 degrees. Let's double check. 35 plus 35 is 70. 70 plus 110 is 180. So yes, we did it correctly. Okay. Let's go to number 6. We have three angles. This is my small angle. This angle is twice this angle. Listen to this because we're going to do some of these in a little bit. And this angle is 3 times the smallest angle. Okay. So when we start setting this up, we would add all our angles. So we're going to go x plus 2x plus 3x. We added all three angles together, and that's going to equal 180 degrees because we know when we add the three angles up, it's going to equal 180. Right. Now we look at this, we go 1x plus 2x plus 3x is 6x equals 180. We divide both sides by 6. So we know that that small angle, x, is going to be 180 divided by 6, which is 18 divided by 6, which is 3 with a 0, so 30. So x is 30, but we need to go back and find all these angles. So this guy's 30 degrees. This would be 2 times 30 degrees, which would be 60 degrees. This would be 3 times 30 degrees, which is 90 degrees. So again, if we look at this triangle, we could classify this triangle as a right, and this guy is going to be scalene. Over here, this guy would actually be, we'll look at this a little bit more next class, but this guy has 2 equal angles, so it actually has 2 equal sides, so this would be obtuse isosceles. Alright? Alright, the next two right here, again, some big point problems right here. Again, you're looking at 2 points for the equation, 2 points for solving it, and maybe another point for going back and finding all these angles. Okay, so we set this up. We're going to take our angles, x plus the other angle, which is 2x, plus the other angle, which is 2x plus 15, equals, when I add all three angles in that triangle up, it's going to equal 180 degrees. Okay, now, remember, when they're on the same side of the equal sign, you do what it tells you to do. That's 1x plus 2x plus 2x. Well, it's 5x plus 15 equals 180. And here we go. We're going to subtract our 15. So that's 165. So we have 5x equals 165. And we divide by 5. And x is 33. Okay, so this angle, or x is 33. That means we can go back in and find our angles. This smallest acute angle is going to be 33 degrees. This is going to be twice that, double that angle, so this would be 66 degrees. This would be twice that angle, twice that small angle, which is 66 plus 15, which would be 71, 81 degrees. Okay, so now we can double check ourselves. If we go right down the horn, we go 33 plus 66 plus 81, that should be 910. That should be 10, 18, 180 degrees. Beautiful. We are correct. All right. Now, number 8, again, this is the same type of problem. To me, number 7 should be harder, but for some reason we make more mistakes on something like number 10. We start adding these angles up, and we go 5x plus 10 plus 2x plus 10 equals 180. Well, now if you look at that drawing, we did the 5x plus 10, we did the 2x plus 10. We forgot that 90. For some reason, that's something we do a lot. Kids do a lot on this problem, is they forget that 90. Plus 90 equals 180. Now again, we have something on the same side of the equation. 5x and 2x is 7x. And then we have 10, 10, and 90. Well, that's going to be 110 equals 180. These are good algebra skills. Minus 110, minus 110. 7x equals 70. Divide by 7. X is 10. So this is 10. Now we need to go back and find the missing angle. So we have to substitute in. And I'm just going to draw it right in the drawing. 2 times 10 is 20. 20 plus 10 is 30. Okay, well, now start thinking. This is going to have to be 60. Let's see if we're right. 5 times 10 is 50. 50 plus 10 is 60. This is 60. How did I know that had to be 60? Because 30 plus 90 is 120. 180 minus 120 is 60. So we had to be 60, and we were. So we were good to go. All right. Now we're going to talk about the exterior angles theorem. The exterior angles theorem, very, very, very similar to the interior angles theorem, but it deals with the exterior angle. So what I'm going to do is I'm going to put some numbers in here. Let's say that this guy is 80 degrees. All right. Now let's say this is isosceles. So let's say that this angle is equal to 50. Okay. And then let's say we're trying to find this guy out here. Well, there are two ways to do this. We could go a roundabout way, or we could use the exterior angles theorem. Now the roundabout way would be to say, all right, well, since this is 80 and this is 50, this guy over here has to be, well, 80 plus 50 is 130, so we'd have to take 180 minus 130. That would give us 50, but that gives us this angle right here. Okay. Now we're going to go back in time. We're going to go back to last chapter, actually chapter 2. If we look at these two angles right here, now I can extend this out a little bit. If we look at these two angles right here, they form a linear pair right there. So if this guy is 50, then this guy over here has to be 180 minus 50, which ends up being 130 degrees. How about that? We already had that number once. Okay, so here's the exterior angles theorem, as short and sweet as I can give it. If we want to find an exterior angle, all we really have to do is take these two opposite interior guys. Now, again, we could go the roundabout way, add these together, get 130, take 180 minus 30, get 50 here. But then we got to go minus 180 again, and we're right back to 130. So to get the exterior guy, we're simply going to add the two opposite interior guys. Okay, so that's what the exterior angles theorem says. An exterior angle in a triangle is equal to the two opposite is equal to the I should say is equal to the two opposite interior angles. I should have put sum in there. I forgot to. Okay, is equal to the sum of the two opposite interior angles. Okay, so you can pause this and continue writing that down. I'm going to continue on. Okay, so you can rewind and pause that if you need to get that whole definition. All right, so we want to find the measure of the missing angles in the triangle. So first off, we know how to find y. We could take 65 plus 70, that's 135. We take 180 minus 135. That gives me a value of 45. So x, or y, is going to be 45. Oops, wrong spot here. Y is going to be 45 degrees. Now the reason I put that y in there, which we already did, is continued practice that, but not also, you can look at the roundabout way now. Here's our linear pair. So we could do the whole 180 minus 45 thing, which is going to put me right back at 135, but I just want to show you the quick way, because we already kind of know it. Well, the quick way is just find this exterior guy, you just add the two opposite interior guys. So we take 70 plus 65, 135. Good. All right, now let's go to this next one. So to find the interior guy here, we take 180. We're just going to add these two together. We get 155. But remember, that's the sum of this guy. So x is the sum of those two opposite interior guys. So 155 is x. Well, then all we need to do now is take that 180 minus the 155, and that gives me 25. So this angle right here where y is 25 degrees. So this will be 25. and that would be 155. Okay. Next example, same process right here. So if we want to find x, we need to add these two together. That's 110, 121. Then we would subtract that from 121. Well, we've got to remember that y is equal to those two, the sum of those two opposite interior guys. So that y has a degree measure of 121. Now x, we need to take the 180 minus the 121. That's going to be 59. So x is going to be 59. Now we can double check ourselves real quick. These two guys should add to 180. Boom, we're good. Same process here. To find x, we're going to have to add these two guys together. Now remember, that's the sum of the exterior guy. Okay, the exterior guy is the sum of those two guys. You add those two guys together, you get 125. That's y. That's that exterior angle. Right? Well, now to find the interior guy, we're going to take 180 minus that 125. Now again, we could look at that from the point of that being a linear pair, or we could use that interior angles triangle sum theorem that, hey, all those add up. That's going to be 55. And these two should add to 180. All right. Now, quick review of these guys. Let's go through and label these real quick. Classifying these, we're going to need this next class. This would be right. No equal sides would be scalene. This would be obtuse, scalene. This would be right. Two equal sides is isosceles, right isosceles. And this would be acute, acute, acute. This would be acute isosceles. All right, let's move on to some ideal problems. I'm trying to draw a triangle that has two equal angles, and the third angle is twice the two equal sides. What are the measures of all three angles in my triangle? Now, if you don't remember the ideal process, I is identify. That's identify the unknown. D is define what you know, and in geometry, a lot of times it's going to be a drawing because we have we're talking about a triangle here, but we don't have a drawing. E is get your equations. A is start solving it, to act on it, but we say solve it. L is label. Label your answers. Okay. So if we're going for this, we're trying to figure out what are we trying to find out here. What are the measures of all three angles? So what are the measures of all three angles? Now that's a question, so we need a question mark, we need a capital letter. That is a complete sentence. I would give you 2 points for getting that part correct, for having a complete sentence, capital letter, question mark. D, we have a drawing here with two equal angles, so we're going to sketch a triangle that has two equal angles real quick. Okay, so that's what we know it's going to look something like that. We're not for sure, but it's going to look something like that. That's my D. Now let's get all our information in there. Alright, so I'm trying to draw a triangle that has two equal angles, and the third angle is twice the two equal angles, but I don't know what those two equal angles are. So what I'm going to do, I'm going to set up like this. I'm going to go, hey, here's my equal angles. I'm going to say that this guy is going to be X, and this guy would be X. Okay? That means if I did that, this other angle is twice of those two equal angles, so this guy would be twice of those. And if these are X, that's 2X to show that. Right. Now we can go on it. We have everything in our drawing. We defined everything we know. We can get rid of the word problem. We don't need it anymore. Now if we look at E, it's, hey, get an equation down for this guy. We can use that triangle sum theory. X plus 2x should equal 180. 1x plus 2x is 4x equals 180. Divide by 4. Dividing by 4 is easy. Divide by 2 twice. X equals 45. Right? Now, A, I didn't mention that, but we just did A. E was my equation. A is my solving that equation and doing the work. Alright? So now we need to come back and label in a complete sentence. So we'll have a complete sentence here, and we'll have a complete sentence here. So if I'm grading these and you can get one back and you say CS, and I counted wrong for that, that means you didn't write a complete sentence. So we're going to answer our I. What are the measures of all three angles? The measures of the angles in the triangle are, well, we have this is X, so this would be 45 degrees. This would be 45 degrees. This would be double that, which is 90 degrees. Alright, so I'm just going to label it 45 degrees, 45 degrees, 90 degrees. Now, every sentence ends with a period and begins with a capital letter. So again, if I don't see that capital letter or I don't see that correct punctuation, I'm counting off. You guys are sophomores. We're sophomores, juniors in high school. We should be able to write a complete sentence. All right, last one. Ideal. I have a triangle that has one angle that is twice the smallest angle, and the other angle is 3 times the smallest angle. What are the 3 angle measures in the triangle? So again, let's go ahead and draw a triangle. Now I don't know what this triangle is going to look like, so we're just going to go ahead and let me get a different type of triangle here. I kind of have an idea what this is going to look like. Maybe you do, maybe you don't. Alright, so here's our triangle, and we'll use this in D here in a second, but we need to label our eye. So what are the 3 angle measures in the triangle? That's our eye. Capital what are the 3 angles in the triangle? Okay. Am I a big stickler on spelling? No, but I think you should be able to spell these words. We're not getting too difficult. So, and every question ends in a question mark. Now, D, defining what we know. To define what we know, we're just going to put it in the drawing since we're talking about a drawing. I have a triangle that has one angle that is twice the smallest angle. I don't know the smallest angle, so I'm going to go ahead and call that X. So we'll call this guy X. And the one angle is twice that, so I'm going to call this guy 2x. And the other is 3 times that guy, so I'm going to call that 3x. Okay, that's everything we have in that question. We don't need this stuff up here anymore because we have everything right here. E, let's come up with an equation. Let's add them. X plus 2x plus 3x, and we know that all the angles in a triangle add up to 180. There's your equation. Now A, remember A was act on it, solve it. So we solve this guy. That's 1x plus 2x plus 3x is 6x equals 180. This might look familiar to some of you. Divide by 6. X is 30. Okay. Well, that helps me find this is 30. This is twice that, 60. This is 3 times that, 90. Okay. So now we can go label my answer, and my answer should answer my question I had. What are the 3 angles in the triangle? The angles are 30 degrees, 60 degrees, and 90 degrees. Period. Every sentence starts with a capital letter, ends with some sort of punctuation, whether it be a question mark or a period. Right? So that's the ideal process. So your homework will be to complete the Math Excel 4.2. You also need to complete the ideal problems that I give you on a sheet of paper. And again, you need a complete sentence here. You need a complete sentence here. And I will promise you that every ideal problem we do, almost every single ideal problem we will do, will be worth 10 points. Okay, and the way I do it is I do 2, 2, 2, 2, 2. That adds up to be 10 points. Okay, so that's 20 points at least if I give you 2, 30 if I give you 3. So good luck on that. If you do have questions, come see me in seminar or before or after school.